पोलीस लाईट राहू द्या, पोलीस लाईट राहू द्या.
Director GHRCE College of Engineering, Dr. presubmission. Dean R&D, Dr. U.S. Wankade. Head Computer Science and Engineering Department, Dr. Malik. Faculty members and dear students, a very good morning to all of you. I, Shubhangi Giripunje, Associate Dean R&D, feel privileged to welcome you all to the PhD pre-submission seminar of two research scholars of Computer Science and Engineering Department. First is Mrs. Smita Nerki on the topic Analysis and Design of Data Mining Techniques for Digital Forensic. And the second candidate is Mr. Prashant Dayivale on the topic Design and Development of Web Crawling Algorithm using various computational intelligent techniques and approach to web mining. Dr. Arun Pujari, Dean School of Computer and Information Science, University of Hyderabad. I would like to invite Dr. presubmission ma'am to present floral bouquet to respected guest Dr. Arun Pujari sir. Thank you ma'am. I would now request Mrs. Smita Nerki to deliver the PhD pre-submission seminar.
A very good morning to all the dignitaries present over here, faculty members, PhD scholar and a PG student. I, Ms. Smita Nerki, welcomes you all for the PhD pre-submission seminar on the topic Analysis and Design of Data Mining Techniques for Digital Forensic. The research work is carried out under the valuable guidance of Dr. R.V. Daraskar and Dr. V.M. GHRCE sir at the Department of Computer Science and Engineering at GHRCE Nagpur. The flow of my presentation will include introduction to the topic digital forensic and the role of data mining in the digital forensic, relevant literature survey on the research topic, motivation behind the problem statement, scope and its limitation, proposed methodology, corpus used for performing the experimentation, implementation details, experimental evaluation, conclusion, future work, published research paper and selected references for this presentation. So let us start with the introduction part. Forensic computing is the process of identifying, preserving and presenting digital evidence in a manner that is legally acceptable. From the law enforcement perspective, it is a scientific method of examining and analyzing data from computer storage so that the data can be used as evidence in the court. So it is the emerging discipline in the computer security and it is an evolving branch. Investigation generally takes place after the incident has happened. It tries to answer the questions why, where and how the incident has happened. The applicable domains where we can apply the forensic techniques include phishing, money laundering, fraud detection, spam detection and the intrusion detection. The steps while performing the investigations are imaging, evidence analysis and evaluation. So the relevance of data mining in the forensic investigation. The one of the phase while performing the investigation is the analysis phase. Analysis phase contains the lots of complex data and it's difficult to analyze that data. For that purpose we can apply the data mining techniques for the digital forensic. Also it is unknown which piece of information may have a value as a evidence at the initial stage. So data mining techniques that have been applied in this area are association rule, outlier analysis, SVM, discriminant analysis and the Bayesian network. The classification of forensic techniques are, they are broadly classified as computer forensic, software forensic, cyber forensic and document digitized forensic. Here the cyber forensic deals with the evidence gathering process and it helps to find out the unauthorized access. Therefore, let's have a look on this cyber forensic. Cyber forensic, as we know, internet has provided us the convenient way to share and exchange the information. At the same time, the cyberspace has opened many ways or new venue for the criminal activities like cyber attack, distribution of illegal material in the cyberspace and computer mediated illegal communication in the big crime groups or the terrorist group. So cybercrime has become one of the major security issue for the law enforcement community. So in this context, the reason behind the cybercrime growth in the cybercrime rate is due to the anonymity of the internet and the decentralized nature of the internet. So anonymity means the sender will attempt to hide the true identities to avoid the detection. They can forge the address. Again, they can route the message through anonymous server and use multiple username to distribute online messages via different anonymous channels. So the possible solution for this problem or for the cybercrime is forensic authorship analysis. Here, the cyber we can able to detect the word print or the right print of the online messages, so that we can able to find out who is the author or who is at the keyboard. So this study proposes the use of authorship attribution approach to solve the problem of identity tracing in the cybercrime investigation. The other potential use of forensic authorship analysis are, it can be used by the intelligence community to identify the pattern of the terrorist. It can be used for the web page scam, malware, pornography, online terrorism posting, web forum posting, phishing, identity theft and masquerade. So challenges for applying the authorship analysis to online documents are generally short in the length. Again, the writing style of online document is less formal and vocabulary is less stable. Structure or composition style of online document is often different from the normal text. And due to internationalization of cybercrime, multilingual problem become new challenge for the authorship analysis. So in this context, there is a need for the research in the forensic analysis of online messages, so that we can able to collect the empirical evidence and we can able to prosecute the cyber criminal in the court of law, and by that way we can minimize the cyber crime. So challenge here is to develop innovative tool and technique to precisely analyze large volume of suspicious online messages. Now moving on to the literature survey. So authorship analysis is classified, or the three main research areas in the authorship analysis are authorship identification, also called as the authorship attribution. Then second is authorship characterization and the similarity detection. Here the authorship identification means we have to find out who is the author of the text, or it determines the likelihood of a piece of writing to be produced by a particular author by examining the other writing style of that author. Author characterization means we can able to summarize the characters of the author by their writing style, and we can create the author profile, and the characteristics that we can extract are gender detection, educational and cultural background and the writing style. Also the third area is the similarity detection. Here we are comparing the multiple pieces of writing and determine whether they are produced by the single author or without actually identifying the author. So here the similarity detection can be applied for the plagiarism detection. So the approach research work is focused on the area of authorship identification, means to can be able to find out the right print from the writing style available. So here the common approach for authorship identification is collection and the pre-processing of data, then extraction of the features, then we can able to apply the machine learning techniques, which machine learning techniques and analytic techniques are useful for this purpose, and the identification of author. So parameters used here or parameters that determines the complexity level of the problems are number of authors and number of available sample documents per author. In literature, this problem is considered as the classification problem. So experimental setup by the various researchers is given here. Here we can say the various researchers and the platform on which they have performed the experimentation. The number of person considered or number of authors considered for the experimental setup are maximum 20, and the number of messages, average message per length and average message per person are given here. Classifiers used in the literature or the previous research are decision tree, neural network and SVM, support vector machine. Most of the researchers have worked on the SVM, and for the feature extraction part, stylometric approach have been used. So stylometry is the study of unique linguistic style and writing behaviors of individual in order to determine the authorship. Here, to trace the identity of criminal in cyberspace, stylometry play important role. Approximately thousands of features are identified in the literature, and but the problem here is there is no generalized feature set available for analysis which can applicable to all people and all domain. So stylometric features identified by the or applied by the previous authors, they are classified as lexical features. They are word and the character based. Example include word length, vocabulary richness, and the distribution of digits and capital letters. Syntactic features are also called as the style marker. Here, example include punctuation and the function word of any one and two. Structural features, they are mainly based on the style or paragraph writing. So here sentence then paragraph line, greeting or signature at the end of the message. These features can be considered as the structure or layout features. Then content specific feature, these are the domain specific keywords and it has some special characters. And idiosyncratic features means spelling and the grammatical mistake, which are generally found in the online messages. So previous research work with the accuracy, the various researchers again have performed the experimentation on the number of author as 10, and here the F1, F2, F3, F4 are style markers, or you can say the stylometric features. F1 is for the lexical, syntactic, semantic, and the F4 is for the content specific feature. So the first researcher have applied the technique of stylometric features for the 10 author, and the accuracy achieved was 95.70%. Another well-known author, he has applied the frequent pattern mining technique for the number of author as a 10 with the accuracy 77%. Then F1, F2, F3, F4, again this feature set is with the accuracy 90. Another approach used for performing instrumentation was K-means with the 90% of accuracy, and the last researcher, he has used again the all the feature set with the accuracy of 97.69%. But here the point is they have all have worked on the number of author as a 10. The performance of feature set in the previous study. Now let's have a look, because features and the analytical technique plays very important role while calculating the accuracy. So performance of feature set in the previous study is given here. So Zheng performed the experimentation on the feature set F1, F2, F3, F4. Here F1 lexical feature with number 87 features. Lexical features considered in this study. Syntactic features F2 157, structural features F3 13, content specific feature F4 as a 10, and accuracy comes out to be, when he tried to apply only the first feature, lexical feature, accuracy is less. When he combined F1 and F2, accuracy is little more than the previous one. And when he applied all the F1 plus F2 plus F3 on the database, then accuracy comes out to be 94.6, and when he has applied all the features, then accuracy is 97.69%. So here the conclusion is, when we are applying all the features combinedly, it is give the accurate result or more accuracy. Then the next experimentation by the Cheng and the Shubhalakshmi, but here the last feature is replaced by the function words. Here instead of the content specific feature, the function words are used, and there are 931 function words are considered here. Here the accuracy, the process for measuring the accuracy is first F1 is considered, then F2, F3, F4, and finally all the features are get combined with this 85.13 accuracy. Another researcher, well-known researcher in this field, Abbasi and Chen, they have performed the 234, they have considered 234 various features with the accuracy of 97.50% when they have combined all the features. Again, in the previous studies, analytical techniques used are classified as statistical univariate method and the statistical multivariate method and machine learning approaches. So in this context, the statistical approaches studied or used by the various researchers are univariate methods, histogram technique, Q-sum technique, naive-based. Then multivariate methods for authorship analysis are cluster analysis, principal component analysis, and linear discriminant analysis. Machine learning approaches include Bayesian, then decision tree, neural network, and the SVM. So the summary of analytical techniques or findings of analytical techniques in the literature survey are: machine learning methods are generally achieved higher accuracy than the statistical method in this field. Machine learning method can deal with large set of features with less requirement of mathematical models and assumptions than the statistical method. The performance of authorship analysis largely depend on the quality of the feature set. So limitation of the existing study is, although the higher accuracy is achieved by the researchers, but it is still challenging to identify the author when the number of candidates increases. Again, when the sample text is short, as in the case of emails or online messages. So it is challenging task. Now moving towards the motivation, problem motivation is existing tools and techniques. There are the various existing techniques to secure the online communication, that is antivirus, intrusion detection system and the firewall, but they are not sufficient to handle the cybercrime and provide the minimal forensic support. Again, the existing tool, forensic toolkit, in-case, coupling and email examiner, these are the general purpose analysis software, and they are not designed specifically for analyzing the textual contents of the online messages. So the research area of authorship identification deal with online messages for criminal investigation. Currently, stylometric techniques can be admissible as evidence in the court of law in the UK, US and Australia. The authorship identification of online messages is a new research area with lots of open challenges. Here challenge is to develop the new technique that will analyze large volume of online messages with the greater accuracy. The use cases for the same, it can be applied to the Twitter messages and used to verify the existing Twitter account and help mitigate impersonation. Then it can be applied on the email and implemented in corporate setting, helping identify anonymous email meant to do the harm. It can be applied for the chat messages to determine the authorship of instant messages, but it is similar to the Twitter, but here the messages are dynamic in nature. Then it can be applied for the for finding the author of terrorist content or by using the contextual analysis. So we can apply this authorship analysis technique, authorship identification technique for the blogs, forums, wikis, email, chat and other forms of the digital contents. So problem statement is defined here to verify the suspect as is or is not the author of a given malicious message, online message mute. Your assumption is that investigator have access to previously written emails of suspect X, and second assumption is have access to emails E1 to E1 or online messages collected from the sample population of U equals to U1 to UN. So here task is to extract the stylometric features and develop two models, training model and a testing model, and classify whether online message or the email who is the author of that message. So problem statement mathematically represented as M is a set of messages M1 to M1, A is the set of author A1 to AM, F is a set of feature set F1 to Fn. So AA of FMA is the mapping function of online messages MI to the author AJ that are defined over FM and A. So scenario in the authorship attribution are there can be three possibilities. First possibility, there can be many authors, there can be many suspects and we have to attribute the text to one of them, or there is only one suspect and we must determine if suspect is the author of the text or not. And the third possibility is there are no suspects and the task is to provide as much psychological or demographic information about the author as possible. So the scope and the research goal, the main goal of this study is to improve the overall accuracy with the large number of authors. My research work deal with the online messages and the maximum number of authors considered are 50, which is more than the previous studies. Our research is concluding with high accuracy for non-adversarial and the investigation of some adversarial cases. So research goal here was to study the existing feature and techniques that are being used in the authorship identification, then comparison of the existing feature and the techniques in terms of the qualitative and the quantitative terms, then to find the possible ways that can improve the performance in terms of qualitative and quantitative attributes. Limitation of the study is the training and testing set used for the experimentation belong to the same data. We have not used the concept of the cross-topic for authorship attribution. Cross-topic data set contain training data from one set, training data from one topic and the testing data from the another topic. Now, on outline for proposed methodology for authorship identification of online messages. So again, the critical issues that influence the performance are feature selection and the analytical techniques. So we need to find out the effective discriminator that can able to identify the writing of one person from the another person. And the analytical technique is the approach to discriminating text by author based on the selected features. So the instance-based approach is used in the proposed method. Instance-based approach means here every instance is considered in the training. If author A has the 3 documents, then all the 3 documents are separately given as the input or feature vector for the training classifier, and the attribution model is checked against the text of unknown authorship, and it will able to find out the most likely author of that document. Again, the outline of the proposed system is the corpus is here. The strategy used is corpus is divided into the training data and the testing data. In the training data, the various feature vector or various techniques are applied to extract the feature, like calculate the frequency of word. Then feature vector is formed. In which feature we want to select, we can select the features, and then the classifier or clustering techniques are used. And this is checked against the testing data. Again, the feature extraction part is performed on the testing data, and the finally we can then able to find out the output of the classifier here. So the stylometric features considered for the proposed systems are lexical features. Here word frequencies and the concept of n-gram is used. Character features means letter, digit and character n-gram is used, and the unique word print of each author is used here. Unique word print means the words generally used by the specific author and which are not used by the any other author. And the finding the text style with co-occurrence of the word. Co-occurrence of the word means the combination of two words, they are formed together. And the approach used is the n-gram approach. Either the word n-gram or the character n-gram approach is used with the frequency of the words. Here the character n-gram and word n-gram means when we are providing the value for n equals to 2 for the character n-gram for the word formation. So it will form the consecutive sequence of the character, two characters. For the formation word it is FO, RM, OR, RM, MA and so on. For the trigram, again it considers the three characters in the formation word. And the steps for creation of the feature vectors is given here. In the step 1, it calculates the word frequency list of all messages in the corpus. Initially, the one matrix is formed for all the messages where the normalized frequency is calculated. Then in the second step, the mean and the standard deviation is calculated for the whole corpus. The next step, z-score is calculated by using mean and the standard deviation. And in the last step, we can able to find out the distance matrix to find out the distance between the two documents, so that which could be the input for the clustering algorithms. So here example is given with the 6 most frequent word and with the 4 authors. Here the author A1 with the word 2.67 gives you the normalized frequency of that word. Normalized frequency here means the W1 occur, how many times the W1 occur in the document A1 divided by the number of words in the document. Then similarly all the normalized frequencies are calculated. Then the mean for W1 is calculated and the standard deviation for W1 is calculated. Same is the process with the other words also. Here the words used W1 to W6 are the most frequent word and authors are A1 to A4. So here after that the z-score is calculated. As we have seen, z-score is calculated by normalized frequency minus mean divided by the standard deviation. So in our earlier example, mean was 2.85, standard deviation is 0.3. Therefore, the z-score for the first word is minus 0.592. So here, what is the use of the z-score? Z-score reflects the extent to which normalized frequency within a particular text are above or below average. When the value is negative, means that particular word is less frequent compared to the other words. So another matrix with the z-score is formed here. Then the z-score table for the two documents is calculated. So again there are two documents A and B. So we need to find out the difference between the two documents in terms of the z-score. ZA for the W1 is this minus 0.592 and 1.412. So ZA minus ZB comes out to be minus 2.004. And then after taking the mod operation there, all the values will be converted to the positive values and total is calculated. And n is the number of words considered for the analysis. If I have considered the 6th word, then I have to divide 8.664 means total of ZA minus summation of ZA minus ZB by the total number of words, that is the 6. So here the distance table is calculated for the previous example. Distance between A1 to A1 is 0. Then A1 to A2 is 1.44, A1 to A3 is 1.03 and so on. The distance table, for distance table the formula used for calculating the distance is Euclidean formula, that is distance between A and B is calculated as 1 upon n. N is the number of words here, and then mod ZA minus ZB. So the technique applied in my research work are, I have categorized the techniques as a statistical approach and the machine learning approach. I have applied the SVM, NIO-based and KNN technique for the features that just now we have discussed, and the statistical approach as a cluster analysis, and the multi-dimensional scaling approach is used. So corpus used, benchmark corpus is used for the experimentation purpose. The first data set used is the C50. C50 data set is downloaded from the UCM machine learning repository. It is made available for this experimentation purpose. It contains total 2500 documents at the testing folder and 2500 documents for the training folder. Means 50 with the 50 authors and 50 documents in text format. Then another corpus used is the Enron corpus. Enron corpus was made public during the legal investigation of the Enron corporation when it was bankrupt. So current version contains the 619,446 messages belong to the 158 users, and data set is collected and prepared by the one project, that is the CALO project. Then another corpus used is the Brennan-Gradstad corpus is used. This corpus was prepared by the Drexel University. They have taken the writing patterns of the 12 and 45 different authors, and they were colleagues and friends, and the topic given to them was the demographic. They need to submit the 5,000 words for the demographic survey. So implementation details. The technology used is the R languages. Nowadays R programming language is the popular tool for the computational statistic visualization and the data science. It is popular language for data science research in academia and industry. Another tool used was the VECA tool, that is Vekato environment for knowledge analysis. It provides support for the whole process of the data mining, including preparation of data till the results of the learning process. Snapshot showing this snapshot showing the feature selection process here. Here we need to select the features, either word or character we need to consider in the analysis with the size of n-gram as 1 or 2 that we have to select. Again we have to tick whether to consider the preserve case option or not. Then the most frequent word settings, we can set here, we can provide the maximum and minimum range for the frequent word that we want to set with the increment of the, here you can give the 100 or 10 or anything. Then the culling option is used. Culling option here means how many number of words we can include in the analysis. Means if it is 50 means that 50% of that word should be available in the all the documents, and when it comes to be 100 means that every word should be available in every document. When it is 0 means all the words are considered in the analysis part. Now this snapshot showing the techniques that we have to select, KNN, SVM, NIO-based. Then the which distance we have to select. Again the options are given for the SVM, linear and polynomial kernel that you have to decide, and the KNN option is also given to state the value of the K. So experimental evaluation study is done with the aim that given a special characteristic of online messages can be able to identify the author of online message. Then the second aim is which type of writing features are effective for identifying the authorship of online messages, which classification technique are effective for identifying the authorship of online messages, then to what extent we can apply this technique on the online messages with different number of authors and messages. So experimentation with the first approach is the machine learning approach. Here the authors initially authors consider 5, then 10, 15, 20 authors and different subsets of messages 10, 15, 20, 25, and gradually increasing the messages as well as the number of authors here. And we have repeated this process for the SVM NIO base on the both the dataset Enron and the C50 dataset. And the prediction accuracy or the accuracy is calculated as the number of messages that are correctly identified by the total number of messages for that author. So initially Enron dataset is considered, total number of author when considered 5 with the training set 62 and testing set as a 10, accuracy comes out to be 93.3. In the same way when it is 50 and when you are considering training set as 650, testing set as a 20, so accuracy comes out to be 78%. So here we can say that accuracy is not decreasing all of sudden. It is initially it is 93 for the 5, but 50 is the 78. Which was the 20 to 40% for the previous cases. Now the experimentation for the when we are considering the SVM and the word unigram equals to 1. Here the C50 dataset is considered. Number of authors are increasing 5 to 50. Training set, testing set, and the accuracy comes out to be here when we are applying the SVM. For the SVM, it gives the accuracy, great accuracy. Even the number of authors are 50. So this shows the comparison of the authors with the accuracy. Then the experimental results for the various features. I have considered the various features for the analysis purpose. Initially applied the character unigram. So this is the accuracy. Then character bigram. Then word unigram. And then the word bigram is applied here. For the C50 dataset with the two classifiers SVM and NIOBase, and for Enron dataset with the SVM and the NIOBase. Now this is the graphical representation of that values. Now procedure for evaluating the performance of the BJ corpus. BJ corpus is used next time with some modified feature set. So here the number of authors again consider from 2 to 45. Maximum number of authors available in that corpus are 45, and initially SVM is applied, and this is the accuracy here. And when we are applied the NIOBase and then KNN, training samples and the testing samples are given here. When they are more, like for the 40 authors they are 455 and the testing samples are 142. So evaluation of various most frequent words on the accuracy. Again, the another parameter is how many most frequent words we are considering in the analysis. Initially I have considered the 100 word for the analysis on the BG corpus with the SVM classifier. So the accuracy comes out to be 100 when I have considered the most frequent word as a 600. Then when it is 45, the accuracy comes out to be 80. So here the final last row for the MFW most frequent word equals to 600 shows that the accuracy can be increased when we are considering the most frequent word setting as a 600. Means in the analysis if we have considered the 600 words or more than that. Then this is the graphical representation for of the various most frequent word for the accuracy. Now investigation of for the adversarial attacks are done. Adversarial attacks are divided as imitation and the obfuscation attacks, investigated as a part of the research. In adversarial attack, author intentionally masks their writing style. So it has two forms of attack, imitation and the obfuscation. Because it may be possible that for attempting the crime, the author can imitate the writing style of another author, or he can intentionally try to hide his writing style. So in imitation attack, the author tries to capture and use the writing style of another author. In obfuscation attack, author hides their writing style in such a way that he will not be identified as an author of that text. So evaluation of adversarial attacks are, BG corpus is used for the evaluation, and the imitation for the imitation and the obfuscation attack. So table here, the first attack is the imitation attack with the corpus used as the BG corpus, and the training set 113 training samples are used and the 12 testing samples are used. So accuracy comes out to be 1.5%. So this method is immune to the imitation attack. Same is the case with the obfuscation attack. Now the statistical approach used for the authorship identification is the cluster analysis. Here for simplicity I have considered only the 3 authors, and then these are the result for the 3 authors, that is clusters is formed from the distance matrix. The distance is calculated between the documents. So Crosby of 05 and Crosby of 04 means these are the 2 documents written by the same author, they are clustered together, and another author is the A. Pressman 02 and A. Pressman 01. Means this is the second document of the A. Pressman and this is the first document of the A. Pressman author, and they both are clustered together. Here the hierarchical agglomerative clustering technique is used, and again the Crosby 05 is similar, distance between the Crosby 05 and A. Pressman document is less. That's why again they are combined together to form the one cluster, because the approach is from the bottom to top. Another technique for the visualization purpose used is the multidimensional scaling. Multidimensional scaling, the author again they are having here the dimensions, multi-dimensions are converted into the 2 dimension, and the values comes out to be, they are plotted against the graph. The Crosby 05 and Crosby 04, they are together, or because distance between both the documents is less. Again, A placement 01 and Crosby 05, they are again having the less distance, that way they are placed on the graph in this with this scaling. Again, I have compared the proposed method with the existing tool. I have worked on the open source JStylo. JStylo again deal with the to extract the right print of the author. And for to compare the things, I have used the same data set here and with the same classifier, because results for the different classifier and corpus are different. So JStylo tool is used on this BJ corpus, and the feature set used by them are the right print. Classifier used is the SPM. So their accuracy comes out to be 92.03%. And in my proposed method, I have used the word print approach, means word analysis is given as the input for the classifier in the form of the features, and accuracy comes out to be 95%, which is greater than the existing open source tool. So conclusion here is, we have designed and developed a technique for performing forensic of online messages to help the investigator to collect pragmatic evidence by automatically analyzing large collection of suspicious online messages. The analysis is performed on the textual content of message. The proposed technique used the frequency of common word from the training and testing data. Function word usage and unique word usage by each author can work as a discriminator to uniquely identify the plausible author of the disputed text. In our experimental result propose that the word print approach used to identify the writing style of author in this study is accurate and shows accuracy up to 95%. This research addresses the issue of scalability, selection of robust and scalable feature type, finding the appropriate classification and clustering techniques by comparing it with the few existing techniques. Again, the proposed approach is able to identify the author. Then character diagram and word unigram features showed particular discriminating capabilities for authorship identification. SVM outperforms the naive base. Different parameter settings for authorship identification had impact on the performance. Adversarial attack like imitation and obfuscation are also investigated on benchmark data set. The proposed method is immune to this attack and capable of handling these attacks. So future work in this area, it could be experimentation can be performed on the cross-topic data set. Then in word print approach, the words up to 5,000 are considered, so we can minimize this word by again working on the feature selection part and to optimize the feature set. Then more work can be done for the obfuscation and imitation attack. So now the list of paper published by me. So there are the 5 international journal publication plus 1 transaction paper. Here all are available at the Google Scholar citation. Then international conference publication, total number are 6. So here the my Google Scholar citation till date is the 86 with the H index as 5 and I10 index as a 10. All the papers are available at the Google Scholar. Then the citation highlight is one of my paper is considered as a citation for the SCM paper, and one is considered as a citation in the Springer. Again, some statistic on the ResearchGate. I have a total publication download 112, publication views are 395, citations are the 6. So selected references for the preparation of this presentation. Thank you. That's all from my side. I would like to thank the Director of GHRC, HOD, CSC, Dean R&D and all the faculty members of CSC department. Thank you very much.
Thank you for your presentation. I have some, Dean said that I have to give some comments.
Yes.
Is it? So first comment to you. Why are you presenting it? Did you present it? What was your intention? Is it to make people to understand? Then it was not true. If you wanted me to read the presentation, you moved so fast that not a single table could be read. Like
I can show
your
you.
publications are there. These are my publications and you moved around. Who has read those publications? Like kindly don't respond. Listen to me. Now that means you are, listen to me please. If you are not listening and doing that, that means you are not also caring my comment, then I won't give the comment. Then please listen, don't act on that. I am asking you a question. Is that what was your intention of presentation? It is that because your director said or somebody said that pre-presentation has to be done, so do something and come out. Or it is to make people to understand what you have done, or it is to make the experts or everybody to read the slide. Which one of that is your priority? I am asking that.
To make it understand to everyone.
But then tell me one thing, ask anybody,
Okay.
if anybody has understood any method there, tell me out of those methods, any method anybody has understood. So that was one intention. So somehow I felt that you are looking at your slides, you are going through the slides, and you never bothered whether a slide has to be understood or something, and just made a presentation. So in that situation, how do I make a comment? I did not read many of those things because you are moving very fast. And okay, leaving aside that part, coming back to the things, come back to this, that I understand that you have done a PhD or you are doing a PhD, doctorate, and you are going to submit a thesis, and that thesis to be submitted, and because of that you are making a presentation. Assume that. And it is like this, that when you go to some place and fill up a form, then there are certain boxes, small square box, and it will say in the line that, have you been ever arrested? No, tick. Have you been ever taken any loan? No, tick. So have you done a pre-PhD seminar? Just to say yes, you are making this presentation. Your intention was definitely not to make people understand. Okay, just to say yes that you have completed a formality of pre-PhD seminar, you have done it. But then let's talk about the PhD thesis itself. What is new in your thesis? Give me one slide here which is new in your thesis. Can you go to that slide? Which is your contribution.
Sir, I have calculated the accuracy for every method.
If you keep moving the slide, it is of no meaning.
No.
You reach the slide, then explain.
Okay.
See, there are two ways. One is that you show the slide, then start speaking, rather than moving the slide and speaking.
Sir, I have performed the analysis of the existing techniques and designed the method.
Just a minute. You have performed the analysis of existing technique. Okay, is it new?
Initially.
You know,
In the literature, sir.
no,
In the literature, sir.
I am asking you entire thesis. Pick up one slide which is new for you. So you are picking up a slide which is not new then. I am giving you a choice that pick up one slide where it is new. So you are picking up this which is not new. So pick up one slide. Explain, please explain now. What is new here?
Sir, the new thing that we can do in this research is we can consider the various parameters because there is the high
No,
impact
just a
on the
minute.
accuracy of the parameters.
Consider various parameters. Correct?
Feature selection research we can do here.
Wait. We can do is different. You have to make a statement that if it is new, you have to make a statement saying that these are the things already done, this is not done, and that is done by me, hence it is new. These three things, what is done, what is not done, And out of not done, what is that you have done? Okay, in this case, what is that you have done? Please tell. Can be done is not a word. I have done. What is that you have done?
Here I have performed the experimentation with the most frequent word initially considered as 100, for the number of authors as 5 and
Okay.
the number of authors has increased.
Let us
to
stop
45.
here. If you have done an experimentation that any BTech students can do, is it a PhD work? Doing experimentation is new.
For that purpose,
I am asking you new. Please remember.
Yes.
If you say that I have done experimentation anybody can do. What is new about it?
Experimentation with new parameters.
So you tell that I have proposed new parameters.
Yes, I
Why is
have.
that new parameter? Why did you propose?
That is in the proposed methodology.
I don't. Did I tell you that which slide you have to go? You have to go to the slide where you want to. I have asked you whenever it is new, you can say that.
So feature selection method.
Okay, tell me. This is
Here-
new.
Here for the document A1 to A4, I have selected the most frequent word as a W1 to W6.
Full stop. Let's come here. Do you want me to say that choosing most frequent words in a document is new?
Then after that I have
First of
applied.
no, after that is different. What I am asking you only new things. Don't tell something which is existing. You have said I have chosen the most frequent words.
But
Is
not
it
as
new?
it is. I have converted it to the normalized frequency.
Okay, now let's put it. Normalized frequency table is new, or it is done earlier.
So I have applied it for the online messaging. That is the new concept.
So
Earlier
you,
it was applicable
Okay.
for the document that are
okay,
larger
now
in length.
you have come to that. You have applied an existing technique to a problem where it is not done. Is it what is new? Then you are not telling me that. You are only playing around with the slides. So what you are trying to say is that there is a problem. For that problem, there are many techniques available in the world, and some techniques are applied, some techniques are not applied. You have picked up one technique and applied it. Correct? Is it what? Yes or no?
Sir, this concept was not applied earlier for the online messages. Calculation of
Yes.
the normalized frequency
Yes.
word in the Z-score. Feature selection procedure is totally different from the existing word that I have suggested in the
Tell me
proposed
the
method.
feature selection procedure. You have not told me the feature selection. Why is the slide?
Sir, these are about the feature
no,
selection.
this is a numerical example. You may have feature selection procedure somewhere. Now let me come to this. If this is the feature selection procedure, word frequency table is new, is known very well. Normalized word frequency table is also known. Okay, go to the next slide. Now this ZWB distance is also known. Now finding the distance within these two documents by difference of ZWB is also known. Now you can see that. I'll tell you these two slides, and this is also. I am telling you to the dean now. Now here is a case, the problems are known but not referred. So it is a clear kind of plagiarism. But I am not telling plagiarism, you have not given the reference saying that this is proposed by X. Anybody who reads it will assume that it is your method. It is not your method. It is already very well known. In textbooks it is known. And you are not giving references. Understood? So it is not. Now let's go to the next point. So this distance is also known. Now let's go to the next slide. Now that using that distance you are computing the numerical error, numerical example. Go to the next slide. Now using that NF mean and SD, Z score is also known. Yes or no? But you are not giving the reference who has proposed Z score in the text. I am not talking about, you may be knowing, but in the text you are not giving the reference. Correct? Okay. Now with this Z score you are getting this table. Then what else you need? Everything is known. What is new here? Apply into a particular context. Okay. So I will say that You know postcard? Postcard. In my generation I know, that's why I am asking. Inland letters, you know? So, suppose somebody writes a program saying that from the postcard I can read the address. And then you say that no, I have started writing a new PhD thesis because with postcard how to write the address I know, but with inland letters how to write an address I don't know. Can it be called as a PhD? Because you are saying existing technique in a different domain. So from writing in a postcard I can write it in inland letters and take it. So same thing happening here. It is a document available to you. Document authorship is known. Feature selection is known. Okay. Now next question. You have used it for SBM. Correct? And NABS. Have you written the program? Have you written the program of SBM?
Sir, that
Package is available. So you don't know SBM theory?
No, I have confidence.
Can I ask you? NABS and SBM difference? You can ask me. Now, how many authors are there?
50 authors. 50 authors.
SBM can identify all the 50 authors?
It will find out the most possible author, not 100%.
For all 50 it will be able to find? What technique it uses in SBM for this?
SPM.
Ah. Because SBM, does it find out, can it distinguish 3 authors? Yes? So that means you don't know SBM. Because SBM by nature is a 2-class classifier. It can only find out 2 authors.
There are 2 pair of classifiers.
But you did not tell that. You did not. I know, that's why I am asking you. SBM is for 2 class. Then how do you extend it? Have you told anywhere? Because you don't know.
I have gone through that also. 2
No,
pairs of
you have gone through, but is it, see, you have used a program. Okay, so that time there is no contribution. Feature selection, no contribution. Now, where should I give credit for contribution? Now let's go to the experimentation. No, wherever you got that 97%, 92%, that table. That table, next table. Okay. Let's see. Which one of these you are getting the best result? This is your experiment, isn't it? This is your experiment.
I have performed the various experimentations, like feature-wise comparison, and the classifier-wise comparison.
In this table.
Purpose.
In this table.
In this table, I have compared the SBM nowadays and.
Now this is your experiment result.
Yes.
Yes. Which of these is the best? According to you. Name-based first line. Name-based is better than SBM?
Here we can see that
And
SBM.
KNN is better than name-based?
The purpose behind this experimentation is we have to evaluate the accuracy when the number of authors are increasing. When it is 2, it is 89. But when it is 45, it is 69. In case of the naive-based classifier, when it is 97.2, for the number of authors is a 2. But it dropped to the very low value when number of authors are 45. It's come out to be 43. So here the purpose is when we are increasing the number of authors, how is the accuracy? What is the comparison between the number of authors and the accuracy?
Okay, now coming to that point, how many times you have run the program with 2 number of authors?
With 2 number of authors.
How many times when you have written 89%, 97.2% and 100%, how many times this experiment has been run? Only once or more than one?
More than one.
How many times?
It depends on the most.
No, it cannot depend. You have done it.
Yeah.
If you have done it, how many times you have done it, you know. There is nothing called it. I am asking you a very specific question.
Yes.
For 2 number of authors,
Yeah.
in your
6
experiment,
times, sir. Because I have set the most frequently but lowest limit as 100 and the highest limit as 600. So initially it will calculate for the first 100 words. Then 1012 200 words, then 2012, 300 words, and so on. The accuracy is calculated. This is the average for that piece. This is the average.
I am not getting it. Can you explain slightly better?
Yes.
I have not yet understood that. And my question is, you have understood my question?
Yes, sir.
Have you understood?
How many times we need to?
There is no we need to, there is no we need to. How many times you have actually computed in your experiment to get the figure in the first row? That is what actually how many times you have computed in the first row. That's what I am asking.
Sir, for that purpose we need to state the most frequent word setting. Most frequent word,
No,
how many words we
okay,
have
now
to consider?
just a minute. I think I'll ask you. Total how many in your data set, BG corpus data set, total number of authors are how many?
45.
45. So in row number 1 you have taken 2 authors.
Yes.
So out of 45 you have chosen those 2 authors.
Yes.
How did you choose those 2?
Randomly.
Randomly. How many times you have randomly chosen? Only once. So your random program might have taken a 2 which is most suitable to you. Is it not biased?
No, sir. Various experimentations has done.
Then tell me,
Anything can be
if you
done.
have done various experimentations, tell me how many times. I am asking that. Tell me.
Initial table is
But see, the problem is that by changing the slide, it doesn't mean anything. You answer. Do you think you don't remember the name when you are looking at the slide?
Yeah, for the author selection, I have done only once.
Then it is a wrong,
Yeah.
wrong experiment. Then it
For
is a
number
wrong.
of authors equals to 2, I have selected 2 authors only once.
Then it
Then
is a
next
wrong.
time I have selected another 5 authors. Then third time I have selected another 10 authors and so on.
Yes. So each row can be termed as bias. Each row can be termed as a biased one. The 100% that you are taking, have I chosen some other 2 authors, it could have been 45%. Similarly, in the last 40%, I choose something else, it can be 100%.
All the 45 authors, all the corpus, complete corpus is considered here. So there
40
is no
authors. I am talking about
45.
40 authors I am saying.
Yes.
I can choose different 40 authors.
Any 40, yes, out of 45, any 40 we can choose because that is the process while solving
No.
the problem.
So if you, that is what I am saying. If you know the process, you are not doing PhD. You are saying because that is the process. The actual process of experimentation, when you are reporting in any literature experimentation, and if you are choosing randomly, the actual process accepted worldwide for research is what? Is that you have to choose multiple times randomly and get the result multiple times and then take whichever is the average of that.
That can be done.
You are not doing me a favor by saying that that can be done. You have not done it, that's all.
Sir,
You are asking here, but
I meant to say I will do that. I will.
that you are not
Your
saying.
suggestion.
See, that is the process. Standing here, you are not saying that you will do. You are saying that can be done. That can be done by one of your BTech students, project students. But you are not saying that you will do it.
I will do it, sir. I
Please,
will
sir.
incorporate all the changes that you have suggested here. I will increase, I will perform the experimentation by selecting the different pair of authors.
How
If
many
it is
times?
two.
How many times?
Sir, I need your guidance for that.
No, I am here only for an hour to give you comments.
So I will go
if you
through the
need your-
literature to check, okay, how many
So that
times
means,
this
that is precisely I was saying that now you come to, that means when you read the literature of all those, you have not gone through the literature where these things are addressed. You have not read that part of the experimentation where these things are addressed.
So very less research work is done in this online messages, particular online messages which is going on. It is not so mature branch to go through all the experimentation parts.
It is
Mature
possible.
experimentation.
It is, I would not like to argue on that. Any research which is talking about these features, any research which is taking frequent words, any research which is doing document analysis and doing experimental work is applicable here. And whatever little bit you have to, and please remember, there are 2 things I am trying to highlight here. If you are ready to get a PhD degree, it requires 2 things. One is that you must have some new contribution. Second, you must have an overall strong knowledge on the subject. If you say it is not possible to read, that means one side you are not cooking up your background knowledge, and because you are not able to claim what is new here, so you are also not contributing something new to this place. So unless there is something, see, by just comparing existing set of techniques with the existing feature of this thing, what is that you are trying to claim? Tell me. And it is so biased experiment. And you are claiming that SBM is outperforming their best, which people will not believe because it is all biased. So what is that you are trying to, what is new here? Tell me. Or it is just a BTech project, multiple BTech projects that you have done here.
Application of new data set for the online messages to find
Precisely.
out the author of that message.
Can an application of something be a PhD degree? When there is no actual new contribution. As I told you, new contribution is that this is done by people, this is not done. Out of not done, this is what I have done. And I have got this result. Do you have that? And that I could see many places. Now, I was also going through your draft thesis. If you have the copy, please read this reference number if you say. I don't know. But the references are very badly written. Very, very badly written. I could see that your training is not proper. But then I would not like to comment on that kind of things. Now, second thing is that the mathematical equations you are so lazy that you are not interested in typing it, but just copied and pasted a PDF form from there. Okay. There are a lot of mathematical equations here which are just pasted. I don't have to bother about that part also. That is your example. But overall there is a lack of technology. This is my opinion. Hello? 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 No, whatever she wants to explain, she wants to explain. If you want.